We're going to talk a little bit about how movement actually occurs using the nervous and the muscular system. Sorry for that weird delay there, weird dragging out of that word. Okay, and so really one objective, summarize how the neural system causes a movement. And so this is a schematic of how that works. Okay, so notice that you've got to come up with an idea like, hey, I want to move, and then your brain figures out what needs to happen in order for you to move. Then you've actually got to move, okay? But while you're moving, you might have to change your movement, right? So just think about some of the things that you're able to do. Like you walk, and as you're walking, your brain's already said, okay, I'm going to put my right foot, then my left foot, my right foot, then my left foot. And even if you don't see it, maybe you step in a little pothole or something like that. And a lot of times you don't actually fall down. Now, sometimes you do and you get hurt and all that, but a lot of times you don't, right? Your body is able to take the feedback that it's getting and almost immediately make an adjustment, okay? Just think about when you're playing sports, right? We're in exercise science. So someone throws a ball or a frisbee or whatever it is, and it looks like it's coming right at you, and then all of a sudden you realize, and maybe you don't realize this, but the ball starts to curve away from you. Well, you're able to make adjustments oftentimes and catch that ball or frisbee or whatever it is you're playing with. Okay, so general summary, you're going to have some sort of sensory stimulus that's activated by sensory receptors. Okay, it's going to send an action potential to the central nervous system. Central nervous system gets the information and says, this is what I need to do. Okay, and then it sends action potential so you can do that thing that your brain says you need to do. And from there, it goes from the nerve to the muscle. Okay, so when we're talking about a movement, let's break this down, just kind of make it a little bit more general. So you have to come up with the idea, you have to produce the program, and you have to move the appropriate muscles at the appropriate time in the appropriate manner. And if needed, you need to make adjustments. Okay, so just to kind of give you an idea, let's just say that you see something that you want to pick up. So you see an apple on the table, you want to pick it up. So light hits your retina and you go, hey, there's the apple. Okay, and so then you make the decision, I want to pick that apple up. And because this requires movement, you're going to have a signal sent to what we call the premotor area of your brain. Okay, and this is where what's called a motor image or a motor plan is developed, and it's developed into its individual components. Okay, just think about trying to grab something that's on the table. Okay, that's not just like one muscle, that's multiple muscles and some different muscle groups. Okay, and once that motor plan's come up, signals are sent to the primary motor cortex. And then you start and signals are sent from there to say, I need to move this muscle at this time in this manner. Okay. And let's say as you're going for the apple, somebody hits the table or whatever, something causes it to move. Well, you don't just completely miss the apple. You might, but instead what can happen is you can make adjustments based on the visual feedback that you're getting. Okay. And this happens in the cerebellum. All right, so here we go. Let's break it down again. You got to develop the idea to move. So this is in your prefrontal cortex. You develop that plan. What muscles am I going to use? When are they going to be used? How much force do I need? What do I need to inhibit? Do I need to make any supplemental changes? So you might have your supplemental motor area. Once you've come up with the plan, then you've got to activate or execute the plan. Okay, so you send signals to your muscles. These can be excitatory and inhibitory, right? So if you're going to use your quads, you want to inhibit your hamstrings. Or if you're going to use your triceps to have elbow extension, you're going to inhibit your biceps. And this occurs with the use of what are called alpha motor neurons. All right, and we'll get into that a little bit later on in this unit. So then you've got your cerebellum. This is where the adjustments are made. So if all of a sudden your apple starts to move or whatever, your cerebellum goes, actually, we need to reach a little bit more to the right. Then a few other things that are involved are something called the pyramidal tract or the corticospinal tract. And this goes from your motor cortex through your brain connecting to the spinal cord. You got your basal nuclei or basal ganglia that help with the coordination of complex movements. And then you've got the spinal cord, right? So brain goes to your spinal cord, and there's lots of information being transmitted up and down your spinal cord. And so your spinal cord's helping integrate that information. Okay, so just to summarize again, so you've got your visual centers in your occipital lobe, that if you're going to see something, or even if you're running, whatever it is you're doing, you're using your vision most likely. You send signals to your motor cortex to say, this is what I want to do. I want to avoid that pothole. I want to kick that ball. I want to pick up that apple. Okay? And then based on the motor cortex and the motor plan that's developed, you might have to make adjustments. And so that happens with your basal nuclei and your cerebellum. Signals are sent down to the spinal cord, ultimately getting to the motor neurons that you're activating or inhibiting, and then you do the movement. Okay? This is not a simple thing. And many of you, or some of you, or all of you, or whatever, might take a motor learning class where they get into more detail about how we're actually able to move. It's pretty remarkable, the complexity that's involved, but yet for the most part, in healthy individuals, movement's not something we think of. We just do it. But it's really quite a complicated process.